In this episode of FUM0131 machining, we finally get to the heat exchanger, and this one will be made from 10 millimeter cold drawn stock, which is cold rolled stock, and it's very simple thing. I will present it to you now. There you are. It's just a tube which has on the other end we have a place for O-ring, and the other end is has a short M8 thread, and then there will be a 5 millimeter hole all the way through. That's it. There are some obstacles here. It might not suit directly into that one. There might be a need to silver solder this to the other flange and then bend the tube a little bit. But let's see how that goes. It might be that it isn't needed, but I think it is, because otherwise the hot end would not be tight enough. The cold end will stay tight, because there we have this O-ring which is flexing a little bit, but on the hot end we don't. So therefore it might be needed to silver solder it, but that's just business as usual. So, it's late work. So, here we are. This is the stock, this is the lathe, and let's dial it in. Obviously. Oh yeah, okay. Let's see. Wow. I think I got it quite near, just visually. So let's see. Now we need to dial it, really dial it in. So there we go. I think that's 1 millimeter. Okay. I believe no more. There it is. It's inside 1/100th of a millimeter, which is the about the maximum accuracy you can achieve with this lathe. I think the spindle bearings are, they are a little bit random. Yeah, okay, there you are, 1/100th of a millimeter. And now we need to face it. We need to take another 1/10 of a millimeter. Wow, now it's clean. We are making small things, so now we have a small file. Really small file. There you are. So I don't hurt myself on that one. Okay. It should be 8 millimeters deep, the M8, altogether with the and then there will be a thread relief, 6 millimeters for the thread, 8 millimeters outer diameter. So 6 millimeters. So here we zero this thing. 1, 2, 3, 4, 5, and 6. There. Then put the carriage stop. Clean the surfaces. Yeah. And then turn it down. Now it should stop on the 0. Yes, it does. And it really stops. You can hear how it goes. It's not soft stop, it's hard. Then you know that there are no chips in between the stopping system. And now let's touch the outer diameter here. we are. Well, it's 8.95. Now it should become 8.5. 8.5 now. Let's see how it is. Well, it's 8.5. Quite exactly. Sometimes this weight surprises me. It's quite accurate. Well, yeah, okay. So the last half millimeter, because now it well, this is just a major diameter for the M8 thread, so from here, like that. So now what we need is the 45-degree relief there, but there should be also a thread relief. So I will put a screw into there. 45. Oh, this is... Then I can move this to a correct place, so I can measure it someday. There you are. So we can actually lock this one there. Here, put some cutting oil there, and then we'll do this thing. It should be there. Okay. This is really horrific. Okay, now. And since this was like 8, and we are going to down to 6.5, 6.4, we need to take from the diameter 2 millimeters. Oh. This was first millimeter. So now we are at 7. Remember, there will be a 5 millimeter hole through. So now we should be at 6.5 here. Let's test that one. That should be 6.5. And it is 6.4. It's exactly what we need. Okay, we leave it there. There you should be now. Yeah, now it starts. Yeah. Yeah, you are there. I can feel it. Yeah. Oh yeah. Looks actually very good. And now we of course need to test whether this is suitable for our purposes, whether it goes all the way to the taper. If not, I make it shorter. It should go there, and well, it's very tight at the end. There you go. Now, let's test it again. Much better. It's all there. Good. And remember, this is just to make a center. So the drill starts correctly. There you are. There, let's start drilling. And this is peg drilling with the tailstock, which is really horrible. I don't like this operation at all. Too much speed. This might be too little speed actually. No, that speed was good. Let's see where we are. I think that's more than enough. Yeah, it's okay now. I need to pull it out from the chuck, and then I will part it, and I will come back to when I'm ready to do that. Well, we are going to part it now. So how did I determine the place to part it off? Well, I used this one. I screwed it in like this, like that, and then measured from the back side of there. I know what's the distance from that back side to the other side. I know how much is that. And then I just put the needed amount of material to have the thing for O-rings, etc. And now we will be cutting it on the correct place, I believe. Let's see now. Left the nibble. Oh yeah, I will do the rest for the next use of this material. Okay. Well, now I have set my carriage stop here. It will stop in 8 millimeters, and well, we are going to take this to a dimension of 8.9 millimeters, so it's here under 9 millimeters. So let's take first a half millimeter cut, see how it looks like. Well, by the way, this is cermet insert, very sharp and does a very good job in small tasks like this one. Leaves a very decent surface finish. Not this time. No. Let's see what's our dimension. So I can synchronize my dials with this one. Well, it's again, it's 9.96. 9 point, so let's take it down to 9 millimeters. It should now be that. Let's see, a little bit more speed, I believe. Well, let's see now, it should be quite exactly 9 millimeters now. Well, it seems to be 0.05 of a millimeter over. So we take 0.15 millimeters from that. 0.1, 0.15. And this is really delicate operation, and now I would like to have a lot of speed here. Let's see what happens. I usually get a way better surface finish. This is not very good. This surface finish here is not very good. So let's measure it again. Now it should be 8.9 millimeters quite exactly. Let's see what it really is. Well, it's 8.91. There you can see it. It's 91. Well, I'm satisfied. And now we need a groove in there. So let's take this away, put in our grooving tool. And this one we need somewhere there. It doesn't need to be exactly, the place is not critical. I will put it there. And now, because this is grooving, we need to take care of the speed again. And this one needs to be how deep? So it we need to go to the dimension of 6.2. 8.9 minus 6.2 equals to 2.7 millimeters deep. Well, that's quite deep actually. Is this true? Really? No, from diameter, that is. Let's see the speed. Well, it's there. 2.7 millimeters. Oh, from diameter. Let's see. Okay. That's more like it. 2.7. That's half a millimeter from diameter all the time. 1 millimeter. Now it's 1.5. Now it's 2. And then 2.3. 25, that's 2.5 millimeters now, and now 2/10 more, it's there. There you are, that's the correct place. And what we need to do now because this groove is it's too narrow. We need to widen it a little bit. So 0.5 millimeter. This tool makes 1.5 millimeter wide groove. So we need to move this 0.5 millimeter. No, 0.5 millimeter, like that, and lock the carriage now. Yeah, this should be simple enough operation. Maybe some now 2 millimeters, and then I need to watch carefully that I don't do the same depth here. That's 2.5, and now a little bit more, 2/10 more, 1 and 2. There you are. Should be there. That should be our O-ring groove. Well, yeah. Well, I could actually try it out. First of all, if the diameter is correct. Yeah, it is. There is 0.1 millimeter. It's really sloppy there, as it should be. And then we have this. This is the O-ring. Oh, this was the O-ring. Let's take the tool away. There you are. And now this should go there really tightly, as it does. Sits there, it's tight. Okay, and now I... Okay, we have the O-ring readily installed into the groove. Man. It doesn't come out easily. I know already. That was a big mistake to put it there. But next thing, I will drill a 5 millimeter hole and meet the other hole from the other side, and then we are ready with this one. Well, here we are at the workbench. And actually this thing fits there quite well, no trouble at all. So no silver soldering or anything like that is needed in this case. It fits there quite well. So what I need to do is to put something inside this tube. And now what I have here is some stainless steel wool, and I will pick up some of these strands. Okay, let's see if I can push it down into the... Yeah, I can see it here. So it's there. Let's see. Yeah, the air is still moving. This one is now tight. And then the last one. Let's see how this tightens up. Well, yeah, okay, let's see. Oh yeah, now there is compression. Good. Very good. Well, one thing to do with this one. You know what? I will test it, whether it runs or not. So, does it run? Definitely not. It does not run. As you can probably see, I warmed it really hot. This got blue, so it has been really hot this side. Well, the thermal insulation works really well. It didn't warm at all this side, not a lot at least, but yeah. So, what is the root cause it doesn't run? Well, there are probably, it's sick in many ways. First of all, the design. This design is not a very good one. You should, the displacer should be very different. This is horrible design. And then, well, other than that, if that would have been different, it would have a chance to run. Yeah, it would have. But I decided to go this way, and well, that was failure by design. And well, is machining itself the culprit? No. It has good compression. Everything works as designed, but the design is faulty. So, well, yeah. So, what is this now? This is BONK. I will put a link under there. BONK. What is BONK, you wonder? Just check the URL. You will see what is BONK. So, a piece of art. So, well, this thing, well, it failed. Not miserably, but it failed. And, well, shall I try this again? Of course. I'm not the type who gives up easily. So, yeah, now that I know what went wrong, so maybe the next version will work better. I'm of course disappointed. Yeah, that's. But I have also learned quite a lot about doing things like this. All the milling job, etc., which was involved, it was a learning experience, mainly a learning experience. So in this case, really, the journey was more important than the target. And well, BONK. So what will be next? In the next episode of Finno-Ugric Machining, I'm going to start something that is about my lathe, the tailstock. Let me show you something before I quit this episode. I have been wondering why my lathe turns random tapers. Well, here is the reason. This tailstock is now attached, locked into the vase, and there is this drill chuck which is really tight in the taper, in the Morse taper, and then I have this piece of steel which is again very tight there. And well, I can move it quite easily here around. 0.5 millimeter. Yeah, really. 0.5 millimeter is, well, and if you see the needle is going slowly around there, there is some oil in between the quill and the housing where it is in. So this is sloppy. This is like extra sloppy. And it's, you can feel how it is sloppy. So, this has to change, and I cannot repair this tailstock. It is what it is. I have to make a new one. And here are some of the material I have bought for this tailstock. First of all, there is. Let me show you. This one is hydraulic shaft. It's case hardened, and then there is a chrome on top of it. This becomes the quill. It's very, very exact on the outer dimension. So, and it's well, not easy to machine, but it's doable. And next thing that we have here is this piece of hot rolled steel. It's almost 10 centimeters, 100 millimeters thick, and well, a big piece. This becomes the base of the tailstock. And finally we have this plate here. This one, it's a 45 millimeters thick. This is the base. It goes not the whole thing, but yeah. And well, here we are. Materials for tailstock. So it will be the tailstock, really. And it will be fun to do. There will be some line boring, for example, and quite a lot of milling and precision work. For example, this quill hole in the tailstock, it must be done, well, I don't know yet, but I think line boring is the correct way to do it, and I need to make a tool for that one. Well, shouldn't be too hard to do. Maybe it's hard, but not too hard. So, I will start that process in the next episode of Finogrip machining. Till then, bye!